Well, hey, loves. Beautiful day to you. Welcome back to the Melanin Deep Dive. In episode one, we established that melanin is far more than a pigment, that it is biochemically active, and that it is connected to your stress hormones and neurotransmitters through shared pathways. And that the conversation most people are having about melanin barely accounts for what it actually does in the body. So today we go a level deeper. We're going to talk about the melanocortin system, which is essentially the control center that governs how melanin-derived compounds talk to the rest of the body. And I'm going to say something before we get into that. What I'm about to describe will explain some things about your body that may have felt confusing, disconnected, or like they came from nowhere. They were not coming from nowhere. They were coming from here, the melanocortin system. So what is it? The melanocortin system is a neuroendocrine signaling network. It is built around a family of peptide hormones called melanocortins, which are produced from a precursor protein called POMC or pro-opiomelanocortin. When your body cleaves POMC, it produces several different peptides depending on where in the body that cleavage or bonding is happening and what signals are present at the time. One of those peptides is ACTH, adrenocorticotropic hormone, which tells the adrenal glands to produce cortisol, the body's primary stress hormone. And we talked about that, which tells melanocytes to produce melanin in the alpha melanocyte stimulating hormone. And another group includes endorphins, which regulate pain perception and mood. What this means is that the same precursor protein producing your stress hormone signal, your melanin production signal, and your pain and mood regulation signal is all coming from the same source. So when your stress axis is chronically activated, when your ACTH is elevated, it's coming from the same place as your melanin stimulation signal. That is why chronic stress changes skin pigmentation. That is why perimenopause, which activates the stress axis through hormonal turbulence or that up and down, affects melanin production. They're not separate events. They are the same system expressing itself in multiple locations. So the melanocortin system, it works through 5 receptor types, MC1R through MC5R. And each one is expressed in different tissues and governs different functions. Understanding which receptor does what is where the conversation really gets specific. MCR1 is expressed in melanocytes and is the primary receptor for alpha MSH in the skin. When alpha MSH binds to MC1R, it triggers eumelanin production. And the variants of MC1R that exist across populations account for much of the variation in baseline melanin levels, UV response, and skin cancer patterns that we see globally. Black skin has MC1R variants that strongly favor eumelanin production, which is protective, but which also means that the inflammatory signals that trigger MC1R activation will produce more visible pigmentation responses than in skin with lower eumelanin capacity. Isn't that interesting? MC2R is expressed primarily in the adrenal cortex. This is where ACTH binds to and triggers cortisol production. I thought that was really interesting. I'm telling you, we're going to go really deep in this melanin series. So your adrenal stress response and melanin production operate through receptors in the same family. So when one system is under pressure, the other one knows it. It knows it automatically. MC3R and MC4R are expressed in the brain and involved in energy homeostasis or energy balance, appetite regulation, and the integration of metabolic signals. MC4R in particular has been extensively studied in relation to obesity and metabolic syndrome. Those are conditions that disproportionately affect Black women. The MC4R connection to metabolic health is an area of research that our community deserves to know about. MC5R is expressed in the exocrine glands. Now, we haven't really gone over the exocrine glands, but we will. The exocrine glands include the sebaceous glands in the skin, or the oil glands. It involves sebum production, oil production, and the regulation of skin secretions. For women in perimenopause dealing with sudden changes in skin oiliness or dryness, MC5R is a part of that story. So, chronic stress, POMC, and Black women. Let's get down to it. So let's talk about it's something that is really specific to our community because the melanocortin system does not exist in a vacuum. It exists in a body that is operating in a social and environmental context. What exactly does that mean? And for Black women, that context matters enormously. It matters so much for our community. Chronic stress, the kind that comes from navigating racism, from carrying disproportionate caregiving loads, from the hypervigilance that Black women are conditioned into at a very young age, chronically activates the HPA axis, which is the hypothalamic pituitary adrenal axis. And the HPA axis and the melanocortin system are deeply intertwined. They're so deeply connected. Chronic ACTH elevation driven by chronic stress creates a sustained signal to both the adrenal glands and to the melanocytes. This is one of the mechanistic explanations for why Black women experience higher rates of hyperpigmentation, melasma, and post-inflammatory pigmentation than populations with lower baseline stress burdens. It is not just about sun exposure. It's about what chronic stress does to a system that is already highly responsive to those signals. Perimenopause, menopause, and the melanocortin system are all intertwined. Okay? So in perimenopause and menopause, estrogen decline has a direct effect on the melanocortin system. Estrogen modulates the POMC expression in the hypothalamus, which is in the brain. And when estrogen declines, that modulation changes. And when the downstream effects include shifts in appetite regulation, it changes the stress response and alterations in melanocyte activity. So as your melanin, you get older, the melanin production starts to decrease. And we talked about that in the other series. Okay, so go back and listen to some of those. I'll connect maybe the first video, it'll be connected here at the end of this one. So you can select to look at that if you have not looked at that already. Okay, so this is why so many women in perimenopause report changes in their skin tone and in the pigmentation that seem to appear relatively suddenly. It's not just that estrogen is doing less for the skin directly. It is that estrogen's withdrawal changes how the melanocortin system is calibrated. The signals shift and the skin shows it. So we talk directly about skin signals. I'm telling you, it's all connected, understanding what your skin is saying. The melanocortin system is one of the most elegant examples of how the body integrates multiple functions through a single signaling network. Stress, pigmentation, appetite, immune response, skin secretions, all of it is connected. It's all connected. Once you understand the connection, you understand that caring for your skin means caring for the whole system. That is Skin Signals and Wellness Beauty. That is what Love You Studios was built on. And in episode 3, we're going to dive deeper and talk about the pineal gland, one of the most misunderstood structures in the body, and its relationship to melanin, melatonin, sleep, and consciousness. I'm going to repeat that. It is one of the most misunderstood structures, the pineal gland, and we're going to talk about the relationship to melanin, melatonin, sleep, and consciousness. Imagine all of those being connected. So subscribe because you do not want to miss this. Okay? I am Chantel with Love You Studios Holistic Wellness. Thank you so much for joining me. Until next time, it looks good to feel good. So love you.